Hi, Mani. Good morning.
Hey, hi, Raj.
Yeah, I'm just making you as the admin. Just a second.
Sure.
Okay, co-host. Okay, currently you're the co-host now. Can you try presenting the screen? If I'm able to see, I'll just confirm you.
Sure. So you want me to share my screen, is it?
Yeah. Because at that moment we should not have any issue.
Yes. So can you, one second, I'll just open the PPT.
Yeah. I think we'll be there throughout the session. No problem, but still.
Got it. Yeah.
Even this will go live into YouTube, LinkedIn, everywhere.
Sorry. If,
This will go live into YouTube also.
okay.
Hmm.
Got it.
I'm able to see the screen.
Yes.
Yeah. Seems to be
So
pretty good.
you have shared it in PDF format, I think.
Actually, it's
Okay.
PDF with you currently.
Yes. I'm just downloading the PPT.
Yeah, okay.
Yeah.
Yeah, I'm able to see.
Good.
Okay. But yeah, I think even next slide also I'm able to see here. So the side one, right? Whatever comes in the next also I'm able to read before itself. That was present, stop presenting, maybe.
So I have to remove this. I think now you are able to see only one screen,
Yeah,
right?
only one slide.
Okay,
Cool. No
cool. This
problem.
is
I
okay,
think we
right?
have 10 more minutes. So everything will go as usual, not a problem. So we'll
Yeah.
be able to handle. So only thing, they should not unmute at once and disturb the class. That's the only thing. We'll
So
give
yeah,
that.
they will be able to, if I ask any questions, they will be able to type in the chat, right? And also, I just want one more thing. So if I want to do any poll, create any poll or not, how should I do that? Do you have any inputs on that?
Code, you mean?
No, no, no. I mean, if I want to create any poll,
Poll. Okay, poll in. I think already we have here, right? So can you try that?
which one?
Um, Go to the more option near
More.
screen presentation.
Okay.
So there will be
After,
poll. So now you might be co-host. I think I'll be giving as a host also. So
yeah, because I'm not able to see the poll here, so
one
that's the
sec, one sec. Let me give you a host now itself and try better. So rather
please,
we
please,
try data
please, please.
to host. Can you try now?
So I should click on more, is it?
Yeah.
No, I'm not able to do that. Uh,
Can you make an entire screen presentation and show one so that I'll check it? Because in Zoom host should get that. Now before I have that option. Now I don't have because you're the host now.
I got it. But, yeah. Screen one, the complete one.
Enter screen, yep.
Yeah. So you're able to see the panel as well now.
Yeah, I can see. So can you go to Zoom?
Zoom. Okay.
Our meeting. I think it is in presentation. Can you stop presentation once?
Where was it?
The slideshow you can end it, okay. Maybe currently. So we can put this
Mm-hmm.
after.
Okay.
Participants, charts, react, share, meeting info, apps, record, the more after record. Hey folks, good morning all. Good morning, Leo, Arun, admin. Hi.
So no
So
worries. I'll
yeah.
figure it out.
Meanwhile, Mani, can you make me co-host?
I'll do that.
Yes, if you could participate and give me co-host, that would be helpful.
Yeah. Yeah.
Hey Scott, good morning. Thank you. So I think Mani, maybe we can have that starting slide as the
Yeah.
screen.
Yeah.
Thank you so much. So folks, we'll be with you. I think we have 10 more minutes. So we'll be with you in a while. Okay. So thanks for joining. We'll get back to you shortly. Thank you. Good morning. So thank you very much for joining. Okay, I think most of you people joined from different places. So we do have another 5 minutes. Let's wait for that. Okay. Yeah, main intention of this session, right? So just wanted to have a workshop regarding the current DevOps, MLOps, and okay, all these things. Okay, the current industry changes, industry trends, what is happening, and all those. So just would like to bring in front of you along with the hands-on kind of thing. Okay. So that's the reason we planned this workshop. We'll wait because we do have another 5 minutes, right? So thanks for your patience. Yeah, with respect to your time, we'll start at the, uh, in time without any delay. But yeah, so we'll be back soon with the live and all those. So we'll wait for the people to join more. Thank you.
Hello, sir. Hello, ma'am.
Hi, Rahul. Good morning.
Good morning, sir. Sir, what is DevOps, MLOps, and SRE?
Yeah, you will get to know everything. Okay, once session starts. But yeah, so for the overview, right, already how the DevOps folks where development and operations take at one place. Okay, so similar way, machine learning also. Okay, so where we build the machine learning pipelines and do operations on this. Okay, so this workshop is completed to make you aware of this, what is what, and how this gonna lead the future for us. Okay, everything will be taken step by step to you guys. Okay, so just,
When do
we'll
we
start.
start with the sessions? Excuse me? When do
Yeah.
we start the sessions?
I think we told sub 7 a.m., right? So another 3 to 5 minutes we have time.
I think in the poster it says that this time's Mara. In the posters, you are posted like around
7 a.m.
7.
IST.
Yeah.
Yeah, it's a 6:55 a.m. IST. So another 5 minutes. Okay. Good morning. Welcome all once again. Thanks for joining. Okay. So good morning, good evening, good afternoon. So I think people from various countries also here, right? So really, thanks for joining by taking your time. Okay. So on this weekend. Well, so as said, this DevOps MLOps workshop is completely to make you aware of the things. Okay, what is the current industry trends and how the things going on and all those, right? So today, Mr. Manikanta is with us. He's really well experienced person to the current IT industry, and he's already working into different MNCs. Okay, uh, so he will walk us through the complete session today, right? So the main instructions were, if you have any doubt, you can post into the chat. So unmuting everybody at once, and we are allowing you to speak. Okay, we are not disabling your mics. You are allowing to speak. You're open to ask any questions, but there will be certain time to ask the questions. But in between, to continue the flow of the session, everything should happen in a proper way. Kindly use the chat window. In between, there will be polls and everything, if anything is there like that. So do help us by responding to them. Okay. Right. So yeah, thanks for joining once again. So over to you, Manikanta. Thank you.
Thanks, Raj. Hi, everyone. Good morning, good afternoon, and good evening. So I see energetic people joining in the workshop. And so I'm Manikanta, but most people just call me MK. Folks at onsite used to struggle with my full name. So I said, all right, let's keep it simple. And MK works, and it got stuck. So everyone can call me MK. And coming to my intro, I had around 9+ years of experience across DevOps, SRE, and now MLOps. So over the years, I have chance to work with different cloud platforms, tools, and technologies. And one thing I learned is like don't chase behind the tools. Master the fundamentals, and the tools will automatically follow you, right? So let me be clear, this isn't one of the workshops where we just play with the prompts and kill the time. And you're giving me your valuable 3 hours of time, and my goal is to give the value back through solid concepts and real technical depth and practical insights. And I'll share a quick story. So a while back, I attended a workshop that promised a Gen A and Agentic AI with hands-on practicals. I thought, great, yeah, they'll show us how to install, setup, and run real examples. And I thought I had went with a lot of expectations. And but what actually happened? Instead of teaching all that, they spent the whole session showing how to type prompts into ChatGPT. And here's the funny part: I'm already premium user for the ChatGPT, and I know how to give good prompts. And honestly, I was building better insights than the trainers themselves. you know so that day I realized expectations can be high, but delivery has to be fulfilled, and it should be matched, right? And that's why this workshop is a bit different compared to other workshops in the market. And this is not about fluffy or wasting time. So it's about real concepts and practical knowledge. And I'll make sure you leave with the confident and satisfied. And yeah, so I'm really excited today because this workshop is not about just connecting the three worlds, that is DevOps, SRE, and MLOps. And these are not just buzzwords. These are the backbone of how modern companies like FANG, Facebook, Google, Netflix, and they run their systems in the backend at scale, scalability, and accuracy, reliability, and availability. So by the end of this session, you will take away why DevOps was created, and how SRE makes systems reliable, and how MLOps ensures machine learning models actually work in the real world. And you will see how they fit together, and you walk away with the practical knowledge for the real projects. And sure, let's keep this session lively. I'll share some stories, examples, and also I'll ask a few questions along the way. And yeah, so I see all should be energetic, and make sure you post your queries. You can pause me anywhere. And all right, so I'll just start with my previous experience, right? I started my career in a data center, that is Tata Teleservices. I think some might know that Tata Docomo project, so that's a Tata Telecom service. So the tagline was "Do the new," and now it's so new that it doesn't even exist anymore, right? And back then we had a massive setup, 1,000+ pieces of hardware, and it was like walking in a hardware jungle. And Dell rack servers, Oracle, HP Unix, whatnot, you name it, we had that hardware. I mean, it's almost a decade back, and that's where I truly learned how physical servers work and why we didn't just restart the services. We actually pulled out the hardware, swapped RAM, we played with our hard drives like motherboards, and first everything was physical, big, noisy, and now if you understood near them, and you would hear losing your you would lose your hearing, or you get a free sauna session. Right? And then came virtualization, and suddenly we were like magicians. Tada, like one physical server is now 10 virtual ones. And now we are in cloud, which basically means all your servers are someone else's problem. And so I just want to have one quick question. How many of you are on development side, operation side, and data science side? Just post your uh, who are from the data development side, who are from the application side, who are from the operation side. Just post your queries, in the chat box. Just post your response in the chat box that yeah, I can see Vijay.
Chat seems to be disabled.
Is it?
Yeah.
Okay.
That shouldn't be the case, because I could see people were responding. Parshram is development side.
It's disabled for me too. Probably for some folks it's disabled.
I can see Vijay and Sanat responding from the ops side, and Vijay into the management side. Great. Yeah, Sasikant, DevOps side already. Great.
So if you have the option to you can directly post to the host folks. Okay, I think you can click on that new chat. It was not disabled for all at all. Yeah, Mani, please go on.
Yeah.
It is asking to invite actually. Once you invite, you will be able to post it.
So no worries. I'll just continue. So Raj, you can fix in the backend.
I'll do that.
So for the next question, they should be able to answer, right? So I can see some people are from data science, operations, and management side even. So those who are from these backgrounds, I can say development side or DevOps or operations or data science side. For them, it will be a bit easier. I can say not easier, but they should be able to correlate the things in their real life. So let's kick off the things with DevOps. Before DevOps came into the picture, most software teams worked in silos. So developer will write one code, and he will just throw to the operations, and operations team will deploy the code and maintain the code in the production. And back then, we mostly followed that's called waterfall method, right? So it's a kind of gathering the requirements and doing the design, coding, testing, and finally deployment. And it looked very good on paper, but it was very slow and rigid. So why should I want to tell you one experience when back decade. Uh, as I told you, I used to work on I'm from the operations background in my initial career, and when we used to deploy a code onto the production, it used to be an NASA release, like a NASA release, like everyone was so hurry and uh, it was like people all over the departments. For example, I am from the OS background. People from different backgrounds like data, backup and database side and the application side, they all used to sit in a war room and we used to deploy it. And if obviously it's going to fail, and sometimes it's going to fail. And again, we used to blame each other, operations and development side, and we used to have again from the starting. So it's a tiresome work, right? So it used to take months or even years for one releases, like which is a very complicated legacy releases I'm speaking about. And if there was a bug in production, developers would blame operations and the operations would blame developers. And then this around 2009, I think so, this culture came, this DevOps, uh, development plus operations. This is nothing, this is nothing a new invention or something. This is just a kind of process improvement, I can say. So it's a kind of development and operations work as a one team to use automation to speed up the delivery icon. So imagine you built a website for your college fest, and developers are busy adding cool features every week, but suddenly the server keeps crashing. Who should fix it? Either developers or operations team. Yeah, anyone, just any guesses? So you can just unmute and you can just speak.
Developers.
Is it?
Operations,
Operations.
DevOps team.
Okay, why operations? If there is a bug in the if there is a bug in the, for example, in the code, how come operations will read the code and they can deploy?
While deploying type, we can give knowledge transfer, right? So knowledge transfer give to team. If something is bug is give, they can handle. If something is still not able to, then the team will contact to developers and they will take solution.
Okay, yeah. So in the backend, what happens is Madhu. So you told they will give the run sheet walkthrough. So that's a called walkthrough session to the operations, and operations team will go through the steps and they deploy it. So usually in most of the scenarios, I'm saying. So what happens is if there is a problem in the coding, for example, they might use the complete loop somewhere. The hardware might take the more memory, right, for one of the process. It might take so much of lot of process, and because of that, server went into hung state. So in that depth, no one can, even the operations team cannot. They will not be aware, right? So how can they aware that? Okay, this process is going to consume a lot of memory. So once they deploy it in, then only they will get to know, right? So that's the reason. So it should be a shared responsibility. For example, it should be a shared responsibility. Both should share responsibility. For example, operations and developers, and that's where the heart of the DevOps lies in. So it's a kind of shared ownership for the entire life cycle. Even the software, even the developers or even the operations, if there is any problem, both should be able to take care, right? And for example, you take I'll just give you a one real-time example. How many of you are aware of the IRCTC? It's an Indian railway tracking ticket booking app. So at morning 10 a.m., thousands of people will try to book tickets at exact same second. You know, now tell me what happens if IRCTC doesn't scale properly at that time? Anyone? So what happens?
Server issue.
Right.
Site comes, crowd will be more, load will
Yeah.
be more.
Yep. Right.
Server crash happens and the website doesn't run.
Exactly. So it's a complete chaos, like crashes, errors, and a lot of angry customers. And so with the beauty of DevOps, the system scales automatically and keeps everyone happy. Well, except the one who still didn't get the tickets. That's a different issue, right? And so whether it's an booking train tickets or streaming a cricket final, DevOps is the kind of secret sauce in the backend that system scales automatically and reliably and alive under the crazy loads, And you speak about take about Netflix, Amazon, Swiggy, whatever. So everyone will roll out their features into the production we can take every minute or every hour, but do you see any downtimes in the back end? No. Do you see any do you see any hang in the applications, for example Amazon or Swiggy or whatever, Amazon or Netflix, in any of the OTT platforms? No. So DevOps allows them to release thousands of changes per day without any crashing the site. So I'll tell you. So I'll apologize for not moving the slide because I'm very poor at these what do we call uh, operating these PPTs because I just don't rely on the PPT and I'll just go with the flow and yeah. So and now coming to the core core principles of DevOps, like there are main four pillars of DevOps, that is continuous integration and infrastructure as a code and automated testing and deployment. And this will be covered in CI/CD and monitoring and feedback loops. So coming to CI/CD. So, how many of you know that CI/CD here? So I think most of the people who are from DevOps or even the data side, they might be knowing the CI/CD, right? It's a kind of used for automatically building, testing, and deploying the code, so software reaches users faster. For example, I think most of the people had been to airports, right? So they had gone through flights, and so if you see like when you enter into the airport, so you see the check-ins, security checks, and every passenger will be scanned, verified, and cleared before moving forward, right? So if you see in India, like there is a DigiYatra, so recently they have made that system. So using DigiYatra, you can just scan your ticket, and you can beautifully everything will be tested and verified, and you will be cleared, right? And if you go into the normal line, it used to be they will verify manually, and they will do the security checks, and they will scan from the back end, and because of that it will take some time. So in the same time, it's a real scenario what I put it before. And coming to CD, so once you are done with the verification or security checks, so you go to the plane, you board the plane, take off, and once cleared, passengers are automatically moved to the final destination without manual delays. So you are seeing the beauty of how CI/CD happens. I just told in a real-time example. Hope you will correlate those things. So we had modern tools for CI/CD. And yeah, so we have modern tools for CI/CD like GitHub Actions, GitLab CI/CD, Argo CD, and Jenkins. Apart from these tools, anyone using any other CI/CD tool?
In my project, we are using Jenkins.
Great. Yeah.
Yeah, Azure DevOps.
Azure DevOps. Yeah. Great. Any other CI/CD pipelines they are using?
Recently heard TechTom.
Yeah, exactly. So recently it's getting popular, right? Tecton. Yeah. And we have TeamCity as well, which is a legacy one. Yeah. So yeah. So most of the people in the industry, they use GitHub Actions and GitLab CI/CD and Jenkins. And who are on the cloud, they might be using AWS CI/CD pipelines and Azure CI/CD. And coming to Argo CD is one of the one which is like, I mean, it's a booming now, I can say. And yeah. Yeah. And yeah. So for example, now it's like an CI/CD is like an assembly line for software, and code is written, tested, and deployed automatically. Every time, for example, every time you refresh Spotify, small updates like new button, or for example, if you take WhatsApp, so in the night they will upgrade it. I mean, you will get a status as a new feature has been upgraded. It has been live delivered through CI/CD pipelines in the backend, right? And coming to infrastructure as a code, and one more thing before going to the infrastructure as a code, I must tell you, every CI/CD is the same. Okay, so even if you take GitHub Actions or Argo CD, whatever, so the concept is still same, you know. And I whenever I take the classes or whenever I speak with the students, I insist everyone to learn the concepts so that you will be implementing the. For example, you take the testing environment. I mean, if you move into the testing path, so there will be only manual testing or automated testing, or it will be in that scenario. But coming to DevOps or this kind of platform, DevOps, MLOps, or SRE, this is a vast. I can say there are multiple tools and multiple clouds. You have to learn a lot, but just learn the concept. Stick with the basics. For example, I'll just tell you one thing. You take the OS, operating system, right? When you speak about the operating system, so operating system is Linux, right? I'll just speak about the Linux because I mostly worked on Linux. If you work on the, you know how Kubernetes has born, you know how now the cloud is there. So I feel cloud is just like a wrapper, and inside that, the main heart of the cloud was Linux. I mean, not Linux; it's an operating system. So in the operating system, you will be attaching the, for example, hardware and networking. So previously, we used to have in the data centers with a huge infra. We used to have networking, hardware, hard disks, and what do we call VPNs? VPNs is in the cloud, virtual private networks, and we used to have Ethernets in the I mean physical data centers. So it's nothing but if you take the main thing doesn't change anything. So if you the core part will not change anything. So if you learned Linux, so I'm just saying master the core concepts. So automatically, for example, if you take MLOps also, so MLOps, what is these agentic AI, Gen AI, so all this came from the fundamental parts, right? Foundation course. So I just suggest everyone to be strong in the fundamentals or foundation. So automatically you will be able to explain, or you will be able to deliver, or you will be able to crack the interviews very easily. And yeah, so hope it makes clear. And now we move into infrastructure as a code. So infrastructure as a code is something like you think of a resume template. Okay, once if you want to write from the scratch, you need to select the template and you need to get the points. You need to build it from the starting, right? And that after you creating with a lot of effort your resume, and you start marketing, and it might, I mean, if it doesn't work, you will wait for some time, and you feel you're not getting some, I mean, calls, and you change it again, you modify it again, and you do it till you get the desired output, right? So this is the same as infrastructure. For example, we used to previously we used to install the OS, and we used to we used to go through we used to have a set of run sheets where we have to hardening the server, we have to install some patches, and we have to do some Ethernet bonding. Ethernet bonding. I think most of the people who are who had worked on the physical servers, they will be knowing that Ethernet bonding. Two Ethernets, they will bond each other so that for high availability. So Ethernet bonding we used to do. So there is a lot of stuff. Now, after coming to the cloud, we used to have the template. We will write everything onto the infrastructure as a code, like everything as a code we will write. For example, you install this. Once you install the OS, you attach hard disk. After installing the OS, you install the patches. After patches, you install the application. So that's how. So it's a kind of reusable template. So, and it's a consistent, and it's fast. And for example, that template can be reused by your peers. And instead of manually setting up of servers, you write just as a code, infrastructure as a code, and thinking. I can give you one more example. So you have a recipe for biryani, and no matter who cooks it, it always tastes the same, right? So if you take the version of that, and you can give that recipe to multiple people, and they will cook in the same way. So that's how it's a kind of version control and repeatable and scalable. If you want to scale it, you can scale with that template, and you can reuse that module. So that's what infrastructure as a code. And we have the Ansible. We have Terraform, Ansible, and AWS CDK, which is getting more popular now, and you will be finding more lot of interview questions. If you are not getting interview questions, if in the backend, when you see some of the job postings, you will be finding this AWS CDK. Might be they will not be asking in the interview because most of the people are not bit aware of this CDK, and because of that they will concentrate on, instead of that, which is a famous tool, that is Terraform or Ansible, or they will ask the basics about infrastructure as a code, right? So apart from this, I think Pulumi, I think, is one more tool. Any other IAC infrastructure as a code you people are using apart from these tools?
Azure Resource Manager templates, Bicep.
ARM templates, yeah.
Bicep.
Great. That's it. So yeah, so these are the popular and ARM templates as well we use a lot, because in the Azure, they will be very useful for scaling the infrastructure, or versioning, or as we can use for infrastructure as a code. And yeah, and now coming to automated testing and deployments, it's a kind of, it will be covered into the CI/CD, and we use popular tools called Selenium and Cypress or PyTest or JUnit we use. And now we are using Argo downloads as well. Imagine you upload your project to Google Classroom, and it checks everything, for example, spellings, formatting before submitting. For example, you take how many of you have installed linting? Have you heard about lint? Anyone?
Yes.
So what does that linting do?
Linters, like for the formatting or for get the errors.
Exactly. So that's what. So it checks the formatting and it's check whether the main work was, it checks the formatting before you push it to the code. And most of the people now, I'll tell you the real world how it works. For example, in my case scenario, uh, in my office, not in my office, most of the office, before you submit the PR in the sense, right, pull request. So before it gets merged, so previously what used to happen, we used to have two reviewers to the pull request, and those two reviewers used to review all the code, and they used to pull it. They used to merge it. Now what happens is everything is automated in such a way that they will be able to we are writing in the backend, so that it will just the lint, it will check the linting, and It will scan for vulnerabilities, for example, say SYNK, right? So I think Sneak tool. So it will use for vulnerability scanning. So it does all the things, and once it passes all the checks, it will just push the code, right? So so there is no manual intervention at all, and it automatically merges. So these all things will happen. So now, coming to monitoring. So I feel observability is much more important and much more like very constant. I mean, it is observability plays vital role in the industry. So why? Because without observability in the sense monitoring. So we call it as an observability and overallistic. And for example, if you take about monitoring, without monitoring, there will be no industry, and there will be nothing. No project will be going to live without monitoring. And there are some famous tools which we use in the industry. Those are Prometheus and Grafana, and we use OpenTelemetry and Datadog and ELKSR. As I told you, it's not like we will be having like testing. If you take testing, or if you take any of the, for example, Java domain, or if you take Python, so or .NET, anything. So you will be testing on only on the .NET, or you will be doing development only on the Java. But when coming to DevOps, so it's a very vast and very huge. Once you get the job, and I'll give you 100% assurance. What you learn, you will not work there. You will be working on different technology. For example, you learned so much on Kubernetes and Terraform, and you are master in that. And once you go there, if it is an on-premise servers, and for example, if you go to the banking, so if it is an on-premise, most of the things will be on-premise servers or their custom uh, Kubernetes servers, or the commands will change, and even whatever changes. So the core concept should be remain same. And I will tell you, I had faced multiple interviews, and I have attended multiple interviews, and I had given multiple interviews, and I'll from my experience, I'll tell you, either anywhere, if you can see, either they ask AWS or Azure. If your resume is completely on, for example, they are having an job description as Azure, and you keep your points on AWS, and somewhere in the next company or the before company, somewhere you keep as Azure, they will shortlist you because they see at the holistic view of you're having cloud expertise about. You got that? So that's where I'll tell you, wherever you go to the next company, or whether you don't expect, or you don't have expectations that I'll be working on only on this. I'll be working on only on particular set of data sets. No. So for example, now MLOps. If you get chance to work on the latest technologies, then you are God gifted. So I feel like that, because so as I told, DevOps is a very vast and very huge. So some might be working on some other tools, and you might be working on some other tools. And they will ask everything. They will start from the Linux, or they may end with the Linux. They will start DevOps, cloud, Kubernetes, and even they will ask you to write on the code, Python code and everything. But just stick to the basics. I'll tell you that, and that's it. You will easily crack the interview. Just correlate the things, and just you deliver you just match the tools. For example, from the Jenkins, what's happening, where it is going, right? From the Jenkins, how the code is getting scanned. So you think in that way, and you just move on, and you will crack most of the interviews, and most of the things. And now, coming to we just spoke about the DevOps, right? So we just now spoke about the DevOps. Now, what But around sometime, Google took this one step further and gave it a name, Site Reliability Engineer. I think you have to concentrate on this SRE because I see most of the jobs are on SRE. And if you have DevOps only, it doesn't fetch you in the industry. So you should be having SRE as well. So what is an SRE? For example, if Google has termed this, it was born at Google, right? And it's like Google has termed this SRE. It's a kind of software, site reliability engineer, And what they thought in such a way that what happens if we treat operations? Why shouldn't they work operations like a software engineers, right? Then if Google, if Einstein and Google were never around, there will be no coding and we will be living happily, right? So we will be sipping chai under a tea and we will be nothing debugging at all. So yeah, jokes apart. So instead of having, they thought in such a way that instead of having just ops engineer manually maintaining systems, why we shouldn't have software engineers and ask them to do the coding, automation, engineering, and that's what SRE in a nutshell, right? And so there are 5 core principles of SRE, that is reliability. And I should tell you this, reliability is something which is very, very, very important. Without reliability, reliable, no application should be there in the production. And there are if everything matters with the reliability. So for example, if you take for example, if you deploy a code into and you had faced one issue and you had fixed it immediately and you had another issue after a couple of days and you fixed it again, and it's not reliable, right? It's not reliant, right? And how come you can depend on that? For example, there is an high load, there is a Christmas, and that is an e-commerce, right? And you'll be having a lot of load, and at that time it might break because it got broke previously multiple times. That is not reliability. So how can you be on that application? How can we so sure on that application? So that's where this reliability, no monkey fixes, right? It should be constant, it should be available throughout the time. And yes, the first thing is reliability, and the next one is SLA, SLO, SLI. So I'll touch base on these SLA, SLO, SLIs and error budgets. Yeah. So what are these SLA, SLO, SLIs? I'll tell you on touch base, and I'll give you a beautiful example so that you will memorize them. And we have error budgets and toil reduction and the monitoring. So these are the 5, reliability, SLOs, toil reduction, error budgets, and monitoring. So these are the 5 core principles of SRE, And now we'll speak about SLI, SLO, and SLA. So what is this SLI? Service level indicator. So what we measure, for example, it's a kind of actual delivery time. SLI is service level indicator, and it calculates the latency and the error time and the uptime response. Sorry. And that is what it calculates. And SLO is a kind of having internal objective. For example, your manager will give you some time to set it, right? So your manager will ask you to do this in a particular time. So that's what you having an internal target. So that is what SLOs are, targets we set. So for example, in your production environment, you want that application to be uptime for 99.99%. That's what SLOs are. And SLAs are something what you commit to the customers. For example, if it's more than 45 minutes, you take about Swiggy or Foodpanda or whatever food applications. So if it's more than 45 minutes, obviously you will get a refund or you will get a coupon. Now they are not giving, that's a different part. But you used to get that, right? So that's what SLA is. There's an agreement between you and the customers. If downtime is greater than 30 minutes, you will get credits or you will get refunds or you will get some discount on the next maintenance of the application, right? So this is what SLAs are. I'll tell you one more thing. For example, So for example, you take the Netflix video streaming. So SLI are service level indicators. So SLIs are what we measure. For example, video buffer time, right? One second. Right. So yeah, I'll just answer to your questions. Yeah, I'll just finish it off, and at the end, I will just answer to all the questions in the chat. So, yeah. Now coming to the Netflix. Sorry, I was coming to the Netflix video streaming. So what we measure is video buffering time. So it's a kind of service level indicator, and objective is 99% of videos should start under 2 seconds. That's what internal target, that is what objective is. And promised, if the service is down for more than 30 minutes in a month, customer gets compensation. So that's what SLA was, right? So, and even you can think of like an cricket who are much fond of cricket fans here. So SLI is like a scoreboard showing the runs, right? What we measure, metrics. Metrics are nothing but latency, error rate, and all. And SLO is a kind of captain's target. Like you have to score 180 runs, and you need to make them out within 2 hours, something like that. Having an internal target, and having an agreement with the fans that if we don't play, you don't book your tickets for the next match. So that's what SLA was. So hope it was clear, everyone. What are SLOs, what are SLIs, and what are SLOs? These are very much, important in the present industry, I can say, because these SLO, SLI, SLAs are something which, if you are attending an interview, if you speak with these kind of words, for example, SLO says, I'll make sure, 90% you will pass the interview or you will get through the interview, because these are the terms I can assuredly say that no one will give you in the workshop that having the core concepts of SRE anywhere and explaining these SLIs, SLOs, and SLAs. And coming to error budget. So this is something very important, very, very interesting as well. For example, it's a kind of balance, innovation, and stability. So what we call it as error budgets. So what does this mean? For example, you have a budget, right? So you have a budget of $100, and you had upgraded a feature, you had done an upgrade, and it got, so you got that upgrade feature from the application team, in the sense from the service, service provider, or you want to enhance their service, right? So you had done that, and what happened? It got downtime of 10 minutes or 20 minutes, right? So that one, they, the service provider, who was service provider, he will not charge you if there is a 10 minutes down, 10 minutes or 20 minutes. They will not charge you for that downtime. So it's a kind of having the pocket money. So in a simple words, having pocket money for you. So you can, it's a kind of allowing SLOs, like internal targets, allowing 0.1% downtime or 0.2% downtimes. You can spend that budget by rolling out new features, or if it causes if it might cause tiny errors as well, but there will be no issues. So this is something we call it as an error budget. So for every application, we will be having an error budget, and it should not cross that, right? If it crosses, then it comes under, you're breaching the SLA, right? So hope it cleared everyone. So does anyone have, now you can post your doubts. So anyone has any doubts on these concepts? Anyone? Oh, no doubts, is it?
Yes, I
Everyone?
think you can post it in the chat also. Maybe it's working for everybody now.
Yeah. I think SJ, who was at SJ? Like DJ. Yeah. So you can ask, you can unmute and you can ask your query here. So at least you can respond how was it understandable way, or do you have any doubts, or how was it?
Yeah, Mani,
Yeah.
Vijay here, Mani. So
Hi,
I'm
Vijay.
not from a technical background. I'm from a manager. Since
Got it.
2007, I'm into management. So I
Got it.
wasn't sure like how I got this invite and all, but yesterday Sucharita, she messaged me. So I joined this one. So
Great.
tell me one thing. So I am a manager, senior manager. So concepts is good. So I'm aware of SRI and DevOps and all. So how it will benefit me? Can you tell me? Because I'm
Exactly.
not, yeah.
So yeah, Vijay. So it will be, see it. Do you think now testing teams, everyone are moving to DevOps, or even the data engineers moving to DevOps? So it's not about you managerial or you, how you get the concepts and you, see, I believe only one thing. Do you think if you go to the, I should not say in the louder this perspective, but I'm just opening it up. So for example, if you go to the next company, Vijay, so do you believe they will check your what you are working in the previous company?
No, what is my experience based on that only? See, I told you no money that I am into manager role. I handled $2 million project, infrastructure project in digital engineering
Okay.
space and all, both FP and T&M kind. I handled like Azure project as well as AWS.
Okay.
So yesterday when I saw this MLOps, right? Because nowadays the hype is more AI.
Exactly.
Recently, 1 week before, I read one article about MIT Sloan, wherein they are telling 95% of the AI projects are getting failed.
Exactly.
So
I'll just touch base on the next one.
okay.
So yeah. So even for example, if you want to upgrade your skills with the MLOps, you can do that, right?
Okay.
So as you told, you are a manager.
Yeah.
You will be managing all the things, right? You will be managing. Even being a manager, I think you are going through the articles and all. You should be knowing end to end what's happening in the industry. For example, your subordinate or your teammate comes and speaks on some random things. You should not say that I don't know this kind of concept. So that's where your expertise comes into the picture, and you can. So how can this be important? That is your question. And everything, Vijay, for managerial kind of thing, I'm teaching. Now the workshop is on completely on the concepts. It's not as I told, it's not in regular workshops, and these all things you can implement in your industry, or you can teach your subordinates. And if you speak with the SLOs, SLIs, or something like with these terminology, I can say, and you see the way how you get the response.
Okay.
Right.
So yeah, I'll take offline money. I think
Yeah,
in the
yeah,
interest of
no
time. Yeah.
worries.
Thank you. Thank you.
Yes, yes.
Hey,
So
quick
yeah.
question. What is the agenda for this 3-hour workshop? I know we've been doing theory for almost like 45 minutes, I think.
Yeah.
Is this the theme of the workshop?
No, there is a demo as well. So
Okay.
once the SRE was done, I'll go into the MLOps. Once MLOps was done, I'll show you the demo of training a model and doing end-to-end kind of creating the endpoints and doing deployment in the doing the deployment in the using Docker, doing the deploy in the Grafana, and you'll see the stats. So that's the agenda of the workshop. So that's what my end goal of the workshop was.
Okay, got it. Thank you.
Yep. Yep. So yeah, I feel everyone was so much interested in this MLOps. Now, yeah, let's move on to this. So um, I'll just tell you the basic journey of how MLOps started in 1960s. So the first neural network, that is perceptron, I think so, was born, and people got so excited, overexcited, thought robots would take over soon. And the reality, what happened? Nothing worked. Like, I mean, results were weak, and funding was very frozen, because I mean, till 2000s there is nothing called of infrastructure, first thing. And some experts system worked in medicine, for example, in the fraud detection model, or in medicine, we can they are like early wins for them. And 2000 to 2010, so that's a kind of comeback where, and I'll just open the slide. Yeah. So in 2000 to 2010, the comeback, like where 2000 in 2006, Geoffrey Hinton, I think so. Yeah. So he revived the deep learning, and thanks to fast computers, then only I think so, like this cloud computing, big data, and AI finally became the useful. And in 2010, AI started moving into the companies. For example, which is in the happily living in a Jupyter notebooks. Jupyter notebooks are something kind of development environment, I can say, and they never made into the production, right? And like students finishing the final projects but never launching them. That's where 2010 to 2015 happened. And 2015 to 19 is something kind of the real boom. Like, I mean, photo recognitions came, and 2018, I think so. Google's BERT, like translators, improved their, I mean, their translation engines. And 2019, GPT-2 shocked the world with text generation, and that's it. So it got funded a lot. It got, every company wanted a piece of that. And in 2020, I think we will be aware of everywhere. AI is everywhere. Now, AI is a part of the daily life, is it? Now, so Netflix recommends your next binge, and Uber finds your next driver, and whatever. Like, you can correlate whatever going in front of your eyes. Everything was AI or MLOps, we can say AI. And airlines, even airlines optimize their routes, and Amazon, Uber sets their surging prices. And I'll tell you one thing here. It's not a normal software. ML is not like a normal software. It's not like a regular apps. Once you build and deploy the code and you monitor it, it works until you change it. No, it doesn't happen like that. For example, you might have in your uh, companies that are legacy applications which were running from past for 10 years, and you don't touch on that. There are so many applications I have seen till they are running right now, but these are not something kind of you can keep having for more years or something like that, because ML models can drift. They drift a lot. For example, a movie recommendation model trained which was trained in 2022 might not work well in 2025, because your taste might change and my taste might change, and the trending changes. For example, you take the OTT platforms. For example, you have the Netflix. You will be getting a lot of recommendations and a lot of enhanced features, a lot of what do we call? I mean, every time when you open a Netflix, you will be seeing something top trending, and top trending in India, top trending in US, top trending in the this week, all these things. So how in the back end is happening because of this data, right? That's why we need MLOps. So I mean, also many data scientists build model in Jupyter notebooks, that is development environment, which are great for experiments, but not reliable for the production systems. So when they deploy into the production, that doesn't work. For example, um, I'll tell you the expectation and versus the reality. And Vijay, or there are some more people who had done, who had asked. So I can tell you this. So the funny part is everyone dreams that ML works like this. Like you train a model, deploy it, and you watch the magic happen. and you get a profit. That's it. But in reality, as you told, 87%, not 87, 90% of projects will never make it into production. So if you ask anyone of you ask ROI for your managers, and everyone will skip that question. Right? So that's a very big question, and that's a kind of debatable still now going on. If you ask ROI, no one will have the question of rate of interest on any of the model. I mean, any of the company, right? So to show the ROI, they will lay off the people. That's a different one. That's a big one. So it takes 9 months on an average to deploy a single model, and most of the 50% of models that do reach production do fail to deliver the value. For example, I'll tell you one thing.
Money, I'll mute her, you can go.
Yeah, sorry. So think like a cooking a dish at home, right? Versus running a restaurant. When you do an experiment, that is not same in the production, right? But in restaurant, you need the consistency, standard recipes, ingredients tracking, customer safety, and you should be able to serve the thousands. That's where this MLOps comes into the picture. In your home, you can cook for the 3 people, 4 people, maximum 10, 20 people. But if it is not good, also they will not say anything. If you say anything, your wife is going to crash you. So that's a different one. But in the production, in the restaurant, that doesn't work, right? So that's the main difference between why we need the MLOps. So it's a kind of going now. I'm telling why MLOps and SRE are much more important is if you see, for example, if anyone wants in their industry to deploy their models into the production, they obviously need MLOps engineer or the data engineer who can upskill his upskill his knowledge. And that's where these MLOps were more important now. And for example, you think of an iceberg, right? So the core part was data scientists. You see, it's just on the tip. And underneath lies 90% of hidden complexities. For example, data pipelines, versioning, reproducibility, and monitoring. And there's a lot of cost associated to this AI and ML, So it's a kind of the tokens cost, and it's not the GPUs, how much costlier they are. And if it is not reaching production, and sorry, so what will they do? So in the last, if someone asks the ROI, rate of interest, so what will they do? So they just lay off the people. That's it. Not lay off, and they do that. Lay off in the sense it's not in that word. So they just crunch the resources, or they just have to show something. So that's where I can say this rate of interest. And so I can tell you in a layman terms what is MLOps. It's a kind of DevOps engineers plus data engineers plus machine learning engineers. It's a kind of set of practices to deploy and maintain ML systems reliably and effectively. It's not a new jobs title, I can say. It's been there from the long back, and it was much more came into the limelight because people started using AI and ML so much. In every company, you need these people so as to deploy their models consistently. And that's where how data scientists, ML engineers, DevOps engineers, and data engineers work together. And the core practices of these MLOps was, so I'll tell you this. So the core practices of the MLOps was versioning everything. For example, code, data, models, configs. For example, you like saving every draft of your assignment so that you can go always back, right? So that is called versioning. And sorry. Yeah. So this is what versioning was. And automated pipelines. So automating the training, testing, and deployment. For example, you like an assembly line, consistent and repeatable, using GitHub Actions or Kubeflow. So these are the some of the tools which we use in MLOps. That is Kubeflow, MLflow, and yeah, these are the main tools. And there are some DVC or model registries for versioning. And we had governance. And I'm telling you now, everyone using AI, and they doesn't still. I told you, still they are in the development phase. And for example, if you speak about the compliance or governance, that doesn't came into the picture till now. I think so. I mean, most of the companies did not go till their governing. And for example, my company, you take, like, I mean, any of the company. So if it is a banking or medical industry, they cannot send every data, they cannot feed everything to the AI, right? They have to mask, for example, customer data. For example, you take the customer credit cards or debit cards, you have to mask the values, you have to mask the names of the customers, and you have to feed the data. You cannot feed the data completely, whatever you get, you cannot feed. So that's where these governance or compliance or this all comes into the picture, governance, right? So, and yeah, so in a simple layman terms, so MLOps versus DevOps versus SRE is something. DevOps is nothing but breaking the wall between developers and operations, focused on most on speed, reliability, and collaboration. How the Swiggy pushing app updates daily without downtime, or even Netflix, right? And coming to SRE, it's like one step ahead of DevOps. It's a kind of SLI, setting SLIs, SLOs. Example, you say Netflix staying up to 99.9% of the time, while still you play the videos, or still you watch the movies, or still you do the surfing on that. Or now coming to MLOps, you take DevOps principles, but ML applies them to ML systems. The challenge isn't just deploying the code, it's also managing the data, models, and drifts, and retraining, right? So examples, like Netflix updates its recommendation model daily, so it doesn't keep suggesting Christmas movies in the June, right? So that's what these three are, the difference between these three. And do you know anyone can tell me, like, how many kind of models do we have in the ML? Anyone, any answer? How many of machine learning models do you think exist?
LLM, non-LLM.
No, those are not. I mean, I'm speaking about machine learning models.
Structured and unstructured.
Yeah.
Supervised, unsupervised, reinforced.
Exactly. Still. Okay. So yeah, I think who had told the supervised and unsupervised. So yeah, so we had 5 models. One is supervised, unsupervised, semi-supervised, and reinforcement, and the deep learning. So I'll tell you how to remember these things in a very layman terms, and you can go out and you can speak with these concepts, and they will think that, yeah, you're very great at ML things, or they can feel your expertise after this workshop. But there are, as I told, there are 5 workshops, and supervised, unsupervised, and reinforcement, and semi-supervised, and deep learning. And yeah, just stick on this. This is not only theory. After this concepts, I'll go to the demo section, right? So it takes around 10 minutes. Just hold your fingers, and we'll go to the demo session, which will be so interesting, and you will be learning a lot, right? So yeah, supervised learning is something I have used in the demo, right? So it's a kind of logistic regression, and it's a kind of supervised learning is something kind of you get the data already with the answers, right? For example, I'll tell you a beautiful example. You give the model picture of cats and dogs. There are cats and dogs, and the label saying which is which. For example, there are a bunch of students in a classroom, and you give the questions and you give the keys. You give the questions and you give the answers to them. So that's what the supervised learning is, right? So it's just a kind of already data comes, answers come with, data comes with the answer. You're just feeding that. For example, dictionary, you give key value, right? So in this way you can understand. So you're just giving the dictionary values to the model and you're asking to learn and it will learn that, right? How many, so this is one thing. And coming to unsupervised learning, that is unsupervised model, there will be no labels. Previously we used to have labels, right? So kind of we used to have dictionary kind of labels, key and value. So here there will be no value, there will be no labels. The model just looks for the patterns. So imagine you walk into a library, right? So with no labels on the shelves. So how many of you might have gone to the libraries, right? So I mean, I think most of all of the people have been to the libraries, or you might have been seeing the libraries, right? So the librarian doesn't know your name, but watches what book you picks, and he takes if you take 3 mystery novels, for example, the librarian says, "Ha, this person likes mysteries, and then I'll show other mystery books." That's exactly what unsupervised learning is. It's a kind of groups of similar behavior, group people by similar behavior. For example, um, there will be no labels based on, for example, every day you go morning walk, you do the morning walk, right? So once you, every day you go to the morning walk and people will observe you, and there will after seeing you, there will be a bunch of people, like almost your colony. I mean, almost everyone in that town goes to a respective place. In a, for example, you take to the park. Everyone goes to the park. So there you observe the people selling from the. They'll snacks. They will start selling the snacks, right? They will see, okay, people coming here, and they will watch your patterns. Okay, for me here the industry, it's going to work out for me. Here the business is going to work out, not industry. So here the business for me it's going to work out. So yeah, I'll establish a business. So something you just watch the patterns, right? Can anyone guess which Netflix feature uses unsupervised learning? Anyone? Any guesses? Just
Is it like OLTP, those things?
not that like OLTPs. So the recommendations, like it just goes through the model. I mean, it just goes through the patterns, the regular patterns. So it studies the regular patterns. So that's what the unsupervised learning does. You got it. So in the Netflix, if you see the recommendations, so that's what it. For example, you watch the movie, you watch 2 horror movies, and it will study your pattern. Okay, this guy is watching the all horror movies. So let me recommend him the horror movie. So that's what the model learning was. Hope it makes clear, right? So it's a kind of patterns. That's what pattern learning. And coming to reinforcement learning. So reinforcement is something kind of, it learns by trial and error and with some rewards and penalties, right? So I think, okay. So yeah. So it's a kind of reinforcement learning is something kind of trial and error, as I told, with rewards and penalties. For example, I'll tell you, in a simple words, you teach your puppy, like for example, teaching a puppy, I mean the dog or whatever, like a puppy. So when the puppy sits on your command, so when the dog sits on your command, you give it a treat. Okay, you give a biscuit or you give something. So that's a kind of reward. You ask something and you get in return and you give them some reward. So that's what. When it choose your new shoes, or when it bites you when you don't give the food, so that's a, you will scold it back, right? So that's a kind of punishment. Over the time, the puppy learns which actions make you happy, right? So for example, the puppy, if you ask to sit, after some time, if you ask your puppy to sit it, I mean you ask your puppy to sit, it will sit, right? So in the same way, that's what replace the puppy with the algorithm. That's called reinforcement learning. It tries something, gets the feedback and improves. And that is what the reinforcement learning was, right? And hope it cleared. That's what it learns by trial and error method, and with rewards, some of the rewards and penalties. So you want some more on this, or you want me to go for another one? So you want me to stress it on this, or hope everyone I mean got what is reinforcement learning was, right?
Hi.
Hi.
Yeah, like so in the reinforcement, like what would be the punishment and reward actually in the like for the algorithm? Like so it keeps on learning and like so it just like if you're saying that punishment is just it'll stop sending those recommendations.
So it's a key signal. For example, it's a kind of positive signal the agents gets for doing something. For example, it encourages the agent to repeat that behavior in the future. That is called reward. For example, in the backend, how they write is like a robot vacuum is there that gets cleaned up. The test, it gets the 10 points. So like that, in a game, the agent gets a score increase for reaching a checkpoint. So that's something kind of positive signal goes to the agents for doing something good. It encourages the agent to do the repetitive behavior in the future. And
Okay.
negatives, yeah, it in the negative signal, in the sense the agent gets for doing something. For example, how many of you use ChatGPT? There are two thumbs up and down, right? So how many of you have ever used thumbs up? So that's a kind of positive and that's a kind of negative. That's a kind of reinforcement learning.
Okay, got it.
Got it, right? Yeah. So it's a kind of encouragement, and so that's how you give it, right?
So, like you said about the second example, right? Second model, right? So, like that also works in the same pattern, right? So it keeps on recommending. If we are not choosing from any of those recommended things, it'll just stop recommending those kind of like if we watch two horror movies, it starts recommending us horror movies based on the pattern, which is as you said. And if we don't like for a few days, if we don't watch any horror movies, it'll just move to the other ones, right? So that's also the same kind, right?
No, that is different, because in unsupervised learning, what happens is it predicts on the patterns. For example, it doesn't know, you don't train it basically. For example, you don't train in the back end saying that I'll watch this movie, this movie, this movie. You don't train that.
Okay, so you're saying that by each click, it just recommends those kind of
Exactly.
things,
It
and
it just
it
goes
doesn't
by
keep any memory back
exactly.
about that.
It
Okay,
goes
got it.
via patterns. Yes, it goes unsupervised
Okay.
learning goes via patterns, and reinforcement doesn't go through patterns. It just what we give it, how we train, it responds based on that.
Okay, got it. Thanks.
Yeah, yeah. And for example, I can tell you one thing. So, for example, anomaly detection, or for example, anomaly detection means customer segmentation. In production, I'm saying, like, I mean, in the real time, how they use for unsupervised learning. For example, raw data is there, unlabeled data is there. So they will for pattern discovery. So these all things they will use for unsupervised. And for example, trail and error methods, interaction, trail and error, and also if you want to maximize long-term rewards, for example, decision making, they will use reinforcement learning. And if you want them, if you want to find hidden structures in the data, because hidden structures in the sense, every structure might be the same, but there will be some anomaly. That's where these unsupervised learnings are used. Right? Hope it clears for you. Right? So
Yeah.
Thank you. So we'll go to the semi-supervised learning, right? So semi-supervised learning is something kind of, it's a mix of labeled data and a lot of unlabeled data. For example, you take a solved problems and solved examples, and one is unsolved ones. It's a kind of for example, I'll give you a beautiful example here. Imagine you're in a school and the teacher gives you a mathematics workbook, and out of 100 questions, only 10 have answers written at the back. You use those 10 unsolved ones to understand the pattern and then figure out the remaining 90 on your own. That is what semi-supervised learning. For example, in the real world, it's used when labeling is expensive. For example, you cannot label each and every data. It was so expensive and tedious work, right? Like in medical imaging, or doctors may label only a few scans, and the algorithms learns from those few and figures out of the rest. So that's where this semi-supervised learning comes into the picture. So it's like, give me a few hints, I'll solve the rest of myself. So that's where this semi-supervised learning, and I think that's a beautiful example, right? Like, give me a few hints, I'll solve the rest. So it's a kind of unsolved data was there, and you can train by solving the existing data. So like having a few solved problems in the textbook and figuring out the rest on your own, right? So that's what these semi-supervised learning are. And now the interesting part is deep learning. So everyone was pretty interested in this, right? So deep learning is not a separate category, I can say. So it's just really supervised and or unsupervised learning with many neural networks. For example, many neural networks. For example, if you take, it's like how human recognize the things. Imagine you see a dog. Your brain doesn't just look once and decide it. Yeah, it's a dog. It's a Pomeranian, or it's a lab. It's an retriever. So it doesn't just go and decide that, right? So what it does, first layer, does it have 4 legs? Second layer, so yeah, it does. Does it have fur? Third layer, like next layer is a kind of like it's having a tail or tail wagging, and okay, that's a dog. And then you will get what is is it Pomeranian or which kind of breed it was. Finally, you will get to that, okay, it's a dog and it's a Pomeranian. So that's how the deep learning does. It has many layers of neurons, each checking small details until it figures out the big pictures, right? That's why deep learning is so good at faces and voices and images, because it mimics our exact brain process information. So whenever you see technology that recognize images, speeches, or text patterns at scale, chances are the deep learning models working quietly in the background. For example, face unlock, you take about the voice assistant, self-driving cars, healthcare, whatever, Google translations, even X-rays and MRI scans in the healthcare. So this is what the deep learning was. So this is how in the backend the deep learning works. So how many of you have used deep learning, maybe TensorFlow, PyTorch, or even just played with ChatGPT? I think most of the people had played with the ChatGPT, right? So in the backend, so that's what the deep learning does. So yeah, so that's the thing. So any questions on top of this? After
But
this,
you have told these concepts, right? Like, so generally, if I want some information, as you told, I can go and put it in ChatGPT and get those things. like use deep learning and all. But like when you talk about real process, like when you want to use these tools and implement some automation work in office,
Exactly.
what do they use? Like when you, for example, when you teach me some deep learning concept here, can I go and use that same in my banking operation, or like there'll be a separate models specifically for my bank? Like I just wanted to understand that part of the world.
Okay. So I got it. So you want to use what are the real-time tools, technology they use in the, what we can say in
Bank.
the,
You can
bank,
you can
exactly,
take a
bank or
bank.
any of the company.
Yeah.
So common ML models, what we use is linear regression or logistic regression, what we call backend, and it's a kind of predicting the number of sales. And so these are something models I'm speaking about. There are LLMs in the backend. So that is something GenAI will do. GenAI, and once you know about these models, you will know where to apply, how to apply, and where to do which use case it will be suitable for your model. So that, which model will be suitable for your use case. So that's what. So for example, we have linear regression or logistic regression. That's where predicting the number of sales or prices, and you predict the outcomes. So that's where, for example, you say the house prices or something like that. So that's where we use the linear regression or logistic, we call it as regressions we use. And we have random forest, which I'll be using in the demo, and the decision trees. So it is something kind of rule-based decisions. So for example, you want to predict the loan, like for example, there is a customer and you want to get the credit score, or you want to predict his, how much can I give the loan to him. There is a kind of prediction, loan approval systems, and all these things, decision trees can be taken by, this model. And tools you use is one is uh, TensorFlow and PyTorch. That is the most we use in the market. And for experiment, for the development I'm speaking about. For now, I'm speaking about experiment. That is MLflow we use, and experiment tracking we use MLflow or DVC. And obviously we use Docker and Kubernetes. And we use, for serving models, we use FastAPI and Flask or TensorFlow, we can say TensorFlow or Torch. TensorFlow, I think we use. And monitoring and observability, we use Prometheus and Grafana. Most of the models we use Prometheus and Grafana, monitoring models in the production. And cloud platforms, AWS SageMaker we use, and Azure ML and Vertex AI. So these are the things what we use. For example, Netflix, they will use clustering plus deep learning. And I think the food apps, they will use the forecasting models and predicting demand. And so this is how. So hope I answered your question.
Okay, just follow-up question. I'm sorry if I'm not.
Yep. No worries. Yep.
Like there is a data from two systems. Like there is one banking transaction coming one, which is from client, and there is
Okay.
one transaction which is our internal. And I want to match the banking transactions which are coming from client and with the internal data. So
Okay.
this we do it manually by seeing by our eyes and using it
Okay.
and those things. So by giving your, I mean, by with your knowledge, if you want to automate these two, what are the models which I can use, and how, where can I start? Like, what should I do like to automate these things?
Got it. So you have two transactions. One is internal and one is external, right? And you want to, got it. So the first thing what you have to do is, so you have to match rule based. For example, so if the transaction ID, amount, date match, if it is matched, mark as matched. And I think you can use SQL or pandas, merge the conditions. And after that, you can use the IDs, or that's how you can see how we are using in our banking. I'll tell you. So we just convert the data into the JSON format, and we feed to the LLM, and we move it to the S3, and from the S3 we feed to the LLM. So that's what we do, right? So in this, you can use the ML model, something kind of record. I mean, it's a kind of entity matching, right? So for example, you do the classification as well, logistic regression. So something you train the data on that, and that's how you can do. You can also do the deep learning if really needed, but it's not required. You can do with the regression, logistic regression. You can use that, as I told, supervised learning. You can do that because you have the both the data. One is external and one is internal. Both the data you have, and you can match them, and you can easily achieve that.
And I can implement this object on, I mean, these logics on Copilot kind of platforms, or should I need to go something external and get approvals? Like,
Yeah, obviously in the banking, right? So everything is it's a very hectic to, first of all, you make sure that's no data from the internal or your external should, I mean, obviously external will be public. Internal.
no money. External is also like a transactional level, right? Like buying and selling. So that is also like restricted only.
Okay, so yeah, so you have to mask the data. You have to write Python script to mask the data, and after masking the data, you have to convert it to JSON, and you have to train the LLM. You have to feed some data with, as I told, supervised learning. You have to do, you have to send both the data, and that's how you can train and you can get through that. You can use LLM models. We have so many LLM models.
Okay.
Yeah. It depends on what your bank uses, which models they use.
Okay.
Yeah.
Thanks.
Yeah. So yeah, now I hope I cleared everyone. So now we go to the everyone which is waiting one, the demo. Hope you can see my screen. Hope everyone is seeing my screen, which is app.py. So can someone confirm that?
Yes,
Yeah.
but can you make it full screen, please?
Yes. I'm just trying it. Right. So I'll tell you in this demo, what I'm doing is in this demo, what I'm doing is I'm just training a simple ML model, and serve it through API, and then monitor using real time. That is, you will see how DevOps, SRE, and MLOps all come together from model training to dashboards. Right. By the end, Grafana will light up with the live predictions, and just like a normal production system. Right. I think just focus on this. I think nowhere in the workshops what you attend might not get this data as well. So for example, we here in the training a small machine learning model, like we use the iris dataset, right? So you can see this. I'm just loading the iris dataset. So which is having a 4 measurements like sepal, length, width, and petal size. And we split the data into training and testing, right? And before I'm telling this, I'm using supervised learning and logistic regression, and you can see the random classifier. I'll tell you why I'm using this random forest classifier as well. Okay. So now what I'm doing is I'm just training this model. What it learns is, I'm splitting the data into the training and testing. So if you can see here, I'm just splitting the data into training and testing, right? And this model learns from the test is what we check on. For example, we split the data into train and test. So the model learns from one part and proves itself on unseen data. For example, there are 100 students, like there are 100 questions. If you take 100 questions and test on the same 100 questions, of course you will score high. All right. You memorize, you by heart them, and you will get the answers, and you just do with that. You just go with the flow. instead, if you study 80 and I will not give you 20, if you learn the concepts, what you're going to do, you're going to answer those 20 as well, which are hidden, right? If you do well, it means actually you learn the concepts, right? You're not just memorizing it, right? So that's what I'm doing it. We train on 100 flowers and we hide 30 so that the model predicts those 30 correctly, and that gives the assurance that it works on the new flowers too. So we have iris flowers, we have almost 300 in the market. I'm giving only 100, you know. Why? Because I'm training only 100. Why? Because like it will be speed, it will be accurate, and also never in the, in the real time also, you don't need to train all the data. So you can train some data, it should be able to work on some remaining part as well, right? So that is what I'm doing it here. And so after training, it will, what it does is, it will save the model, because I don't need to run every time, I don't need to retrain. So what I'm doing is I'm just saving the model. If you can see, model saved as model pkl format, .pkl format. I'm just saving it. So this is what our fast API application will later use to make live predictions, right? And we can check the accuracy as well on the test, because as I told, accuracy, latency, and availability are the most important, uh, what do we call, terminology, or we use metrics to in Grafana or Prometheus, right? So that is what, now we train a model and we get the accuracy of the metadata, and it will be ready to serve in the Grafana. Got it? And now I'll just run it. So we'll see what happens it is. Okay, it will just train the data. Okay, it will just train and it will save in .pkl model. Okay, once it got saved in the .pkl model, now what we are going to do is we are just run the application. We load the model as we have saved earlier. We are going to create two endpoints. So these are the two endpoints. If you are seeing, one is for prediction and one is for metrics, right? And I want to just tell you one thing. So since it's an MLOps and DevOps, I just want to touch base on Prometheus and Grafana. And Prometheus is metric based, and Grafana is something called visualization. So we can create the graphs, we can create the dashboards, and we can do alerts, we can create the alerts. All these things we can do it in Grafana. And Prometheus is something kind of metric based. We can see the what metrics are coming into this, and we can, it's just a kind of collecting the metrics. Prometheus is just collecting the metrics, right? So now what we are doing is we are just creating with this app, we are just creating the two endpoints. One is metrics and one is predict. Why metrics is something we want them to calculate the total number of metrics, right? So now let me run that. So I'm just, what I'm doing is I'm just taking, if you are seeing it, I'm just loading this PKL and I'm just serving the model into two endpoints. I'm splitting the model into two endpoints, and now you should be able to see, one second. So the application started, and So you're seeing the metrics here, right? And in the same way, docs. So you can see the FastAPI, which was the prediction was the model was active, and you can see how. Sorry. Okay. So yeah, you can see the model was active. It was running, and you can see the two endpoints which was created, predict and metrics, right? And now. So now we got the model ready. We have trained it. We got it. We created the two endpoints. Now what do we do? Next thing. So now what we do is we'll create a Docker. I'll just see my Docker is up or not. I'm just starting my Docker desktop. Give me a second. It's just starting it. The Docker is starting.
Meanwhile, Manikanta, can I ask a quick question?
Yep.
So I'm already working as a DevOps engineer in my organization, and in the near future, there will be an MLOps requirement, and I'm trying to upskill on it. So I want a quick suggestion from you. Like, do I need to know the training, these models, this coding of Python and all, right?
No. So that's where the beauty is. See, if you know, you can master up. So see, knowing the things is not a bad thing, but you should know. It's not a compulsory that you should know the model. You should know that scripting Python. You should be able to do. No, it's not the compulsion, or what you will be doing in the DevOps when you upgrade it to MLOps is you just get the models, right? You should be able to build the pipelines. You should be able to see, for example, you can ask them. For example, they build the model. Okay, so you can ask them, can I have the metrics in the model itself? You can ask them. So that's where your what do we call? That's where you can showcase that. Yeah, I know. Okay, he knows about the models, and he knows about the MLOps. Like that, he knows about the bit coding or something,
Yeah,
right?
got it. Thanks.
That's where you can show, but you no need to write the code. So you should be able to build the pipelines. You should be able to do the monitoring setup, which is very important for, I think, DevOps or even SRE. You should be able to set up the monitoring, and yeah, that's what. I hope I answer your question. Yeah.
Yes. So I am assuming that your next steps would be like creating the Docker file and copying these files and running
Yes.
icon as a run
Yes.
the run command,
Yes.
entry point and CMD,
Yes.
and deployment into the Kubernetes.
So Kubernetes I'm not doing right now. So I'm just doing it on Docker itself. So if you can see, I had written a Docker compose.
Okay, using Docker Compose.
Yeah, Docker compose. I'm just opening the image. I'm using Grafana and Prometheus, and there I'm using environments, and depends on the Prometheus, it will go on to the Prometheus, and that's how it's
Any
going.
CI/CD you are currently integrating, or
No CI/CD as well here. So it's a simple training the model, deploying it onto the using Docker, and spinning up Prometheus and Grafana, and configuring in the Prometheus SLI, SLO, SLU. So these three things I'll be showing you, in the sense I'll be configuring it in the Grafana. That's what I'll be doing. And so I'm just spinning up Docker. We can do with sorry, we can do with the Kubernetes, and I have to install Minikube, and we can do that, but so I need to do some more setup here to do that.
Hey, hang on, Kanya. Just a small question.
Right.
Hello.
Yep.
Is this scope going to be mostly to MLOps or DevOps?
So you're seeing it, right? So it's a kind of MLOps, SRE, and DevOps, and you're seeing how we are deploying the model, deploying in the sense creating the endpoint, and we are seeing the metrics, and we are creating the dashboards for MLOps using SRE dashboards. So that's what
You're going to cover the cloud concepts also here in this course?
No, this is the last. I mean, after completing the demo, that was the last endpoint. So I'm not going to cover the cloud.
No, not today. In the course.
Yeah, obviously. So in the course, it will be end to end. Even it starts with the AWS, Azure, and these MLOps concepts, and you will be coming out with an end to end things.
Can we have the course details, like what are the topics will be covered?
I think he will be sharing the further details. I think the guy who was.
We'll share with you complete details. Okay. Hope guys were there in the group, right? Everybody, there is a workshop group, right? If not, I'll post the chat window here. Kindly join there, and I'll update the things there.
And I just want to stress it on one thing. So the future is, I mean, whoever is a bit worried or whoever is thinking about the future that, oh my God, because of this AI, our jobs will go. No. So if you are up to date, for example, if you are up to date with the MLOps, or if you are up to date with the AI, see, MLOps is the basic thing. I feel, for example, after these MLOps, so after these MLOps, what we will get? LLM ops, right? What do you mean by LLM ops? LLM ops is something, yeah. LLM ops is something, I mean, we will be training bit advanced, I can say, more than ML ops, right? And we can, and also, for example, after LLM ops, for example, ML ops is just serving a restaurant. LLM ops is something you manage the complete food court. So that's what you work on, the training, you work on the, what do we call? You work on the training, what do we call? How you prompt engineering, right? So how do you, the prompt engineering, all these comes under the LLM ops. Though, so it's a kind of upgrading step for you. It starts with the ML ops. And as I told in the initial phase as well, if you know the concept, if you are good at fundamentals, so everything starts with the fundamentals. And if you're strong in the fundamentals, no one can stop you, right? Hope I'm clear. So after LLM ops, so it's a kind of prompt management and vector databases and fine tuning workflows and hallucination detection. All these comes under all this comes under starting phases. I can say this is every company was at. There are level 4s. I give it as level 4 levels. One is level 0, level 1, level 2, level 3, level 4. Level 0 is something kind of everyone was in models in notebooks, no versioning, nothing. And level 1 is something kind of automation, basic pipelines. And level 2 is something CI/CD for ML tested deployments. And level 3 is something drift detection, automated operations, retraining something. And level 4 is something full automation, self-healing ML systems and something like that. So most companies today are between level 1 and level 2. So the goal is to climb up this ladder. And as I told, the future is LLM ops, and all these all evolve in the future. So yeah, I think our Grafana and both the instances came up. So you can see in the Docker desktop, 2 images. And so as you know, Prometheus and Grafana. So Prometheus is something which runs on localhost, you know. I mean, which runs on, sorry, not localhost, which runs on slash metrics is something which runs on Prometheus. Okay. Because you will be able to see all the metrics collection here. And for example, you can see how many total, I mean, how many prediction prediction count. So you can see all these metrics. So that's where we created the endpoint called metrics. So if I'll not create that slash metrics, I'll not get this one, right? So I have Grafana, which is running on 3000, and these are the default port numbers. I think in some of the interviews, they might ask what is a port number which runs on Prometheus or Grafana. So Prometheus is something which runs on 9090. So this is how Prometheus looks, and this is how Grafana looks. And now we'll just log into Grafana. Admin. What is it? It will prompt for new password. Here. See, it's boom. We got the, now we got the Grafana. Hope everyone is able to see this Grafana dashboard, beautiful Grafana dashboard. So now, so in this workshop, as I told, we are covering very important one, which is adding a data source. This is common in every company, everything. First, what we need to do is we need to add a data source. Data source is something, nothing but it's a kind of local. I mean, pointing where the data comes. So that's what we call it as a data source, adding the data source, right? And we are adding the data source called Prometheus. Add new data source. And here I'm just giving it, right? I'm just saving it. Save and test. What it does, it successfully queries, this API will successfully hit my local one, and it will say that, okay, it's getting the connection. The connection was established, connection was live. So I can save and test. I mean, I have done this, okay? And coming to dashboards. Now here you will be able to see I'll just create a new dashboard, right? I'll click on visualization. And so in this workshop, I'm covering how to create the dashboard, how to create a dashboard in the Prometheus, how to send the metrics to Grafana. So these all things you are learning. So you see how many things you are learning from the observability perspective, right? So I'm just changing the time. And for example, here, I just want to give a query. Everything queries you will be writing in the PromQL query. Okay. And I'm giving here rate of. So you can ask me, how can you get these? Like, see, rate and all, these are something you have to learn by yourselves, in the sense we will be teaching it. So these are something PromSQL queries. And this prediction count, where I'm getting this. So prediction count total. So you can see here, right? So this is something I'll be getting this from Prometheus, where we previously added the data source, right? So that's where we will be getting the prediction count total. So you see there is something we are getting, the data, some data we are getting, right? And if, for example, you can say, you can remove this one, prediction count, which is nothing, there is no data in the Prometheus. If I do this, run query, you can see no data. So if I'm giving the prediction count total, so you're seeing some data is coming, right? So you're getting this data from here, from the Prometheus. So from Prometheus, where we are giving is from here. So we are creating an endpoint, right, in the app. So you're seeing, right, metrics. So this is where /metrics. So this is where we are sending the data to /metrics, and we are getting the data stored in Prometheus. And from Prometheus, we have added the data source, and from the data source, we are adding it here. Hope it clear. You can correlate the points. You can correlate each thing, how it is working, right? So I'll just save the dashboard. Okay. So this is something total this is something total number. Okay. Total count. Okay. I'll just go to the dashboards, new dashboard. I'll just make it duplicate, or I'll just make it duplicate. I'll just make it duplicate. So, okay, so I'll just, sorry. Right? Yeah. So this is something called availability. I'll create latency and accuracy. So these are the three things. I'm going to create it now. Okay, just be on the hold. This is availability, because total number of, what are the prediction count? What are the predictions happening? Availability, right? Save the dashboard. Save it. And dashboards. And here, edit. Now I'll create the accuracy, model accuracy. So run query. So you got accuracy. What is this? There is no down, because it is running continuously. And because of that, it got 1. It's up. So 1 is nothing but up, 0 is nothing but down. Okay. In the Prometheus. So I'll give the accuracy. Save the dashboard. Yeah. And the third one, where we go is here. This is, so what is remaining? Can anyone tell me what is the remaining one? Yeah, anyone? What is the remaining one? We got accuracy, latency, and sorry. Accuracy, and we got the total availability, and now we want the latency. So I only told the answer, right? So latency, we can get that. Latency is nothing but what is a, latency is something we can calculate that. For example, you are getting a data, how much time it's taking time to get processed. That's what the difference between the time generated and time processed. So delivered, we can say that's what the latency is. For example, you go and open a Google website, or you open any browser. So the time taken for the rotation of the time taken for loading the app, that's what the latency was, right? So we are not getting anything latency, right? So we are just getting some data. I'm just saving it. So now going to the report. So now you're seeing some metrics, but which are not relevant. You're not seeing any data in this, right? So now what I'll do is, so I'll generate the data. I'll generate in the sense I have a small traffic simulator which keeps sending random flower measurements to our /predict endpoint. So this is what, so generate requests. So what it does is it just send the random flower measurements. Because we keep sending requests, our metrics start moving and prediction go counts and latency shows and Grafana panels update live. So basically that is what this script makes sure our dashboard isn't empty, that it keeps the system busy just like real users would do, right? Interesting, right? So I'll do this. Python generate request. So yeah, it's sending the predictions for every 1 second. So now you see in the Grafana, I'll just refresh it. So now have you seen this? Accuracy will be same because it takes on the how the prediction was there consistent. That's what accuracy is. So if you can see this availability and the prediction, total number of predictions have gone up, and even the latency, you can see the latency between those two. That's what. And the latency between the prediction, how it's getting predicted. So you can see the data getting generated, right? So you can see this. So how beautiful it was, right? Yeah. Any questions on this? So it will predict, it will do the prediction of latency, accuracy, all these things. Just like an SRE team would monitor the real production service, and you can go on alerting, and you can create the alerts as well, right? So for example, you go to the dashboard, and this is something out of the box, right? So you can just create, edit, and you can create the alerts as well. Go to the alert and add new alert. So you can create the alert here. So for example, if it is above 1, it should pop up, and you can set the evaluation behavior, all these things like notifications, whom should it contact by Grafana default email, or you want to create something you want to, and the message. So these all things you can configure it by your end. I mean, your end in the sense you can configure it. So that's what it does. Yeah. So how cool it was, right? So how cool these dashboards were. So you can see all the live predictions and availability and latency and accuracy, right? So any questions on this? Any questions on this? Super. I think no more questions. Everyone understood pretty well. Is it? I take it as no as an answer. And yeah, that's the end of the demo. And anything else you want to discuss?
I have joined this class late. We get the recording.
Sorry, your voice is a bit clumsy. I mean, it's breaking.
I have joined this class very late.
Yeah.
Will we get the recording for this one? What exactly you have done, or what we have been taught here?
Yeah, Mani, I'll answer this question. Okay.
Yes,
Yeah,
yes,
Keshav.
thanks.
Yeah. So we were in live into the YouTube also. I think I shared that link in our group. So that will be available 365 days into the YouTube as well as into our LMS portal. Okay. So any of the way you can access them.
Yeah, I think that's it for the today. Any further questions?
Mani, this is Arvind. It's a nice demo. So my question is like, we have done that on a, standalone, right? If you have to
Yes.
scale up, like, let's say, imagine a production system which has like hundreds of servers. How do you see this is going to be different? What you just shown from a single standalone machine to a production environment.
So that's where we have Argo CD and Kubernetes deployments, and we will be scaled. So for example, I have deployed this Prometheus and Grafana on a single source of like I'm on my system, right? So for example, in the Kubernetes, how it will work is I'll be deploying this on a namespace using Helm charts, right? So, and if the Prometheus and Grafana, it will automatically scale when I do the deployment in the Prometheus and Grafana. I mean, using operators, I can say I'll be deploying using operators. How the real world, real time, how we do is using the operators and Helm charts. And once we deploy, we will mention in the Helm charts automatically scale the whatever the pods or nodes it will take. We will be deploying. We will mention as automatically, it will automatically scale to the particular number of pods so that can take the loads, and that's how we can do it in the Kubernetes. That's how we do.
Okay, thanks.
So Mani, I'm Sashi. Is there any flowchart or end-to-end any pictorial representation of the MLOps, like starting from the code, how it pushes to the repo, and from there how the CD starts?
Yeah, it's as I told. Sorry, who is this? Shashi, sorry. So as I told, it is same like DevOps, Shashi. So the only thing is, so here the change is, as I told, the data retraining and versioning, and it is same like what we use the tools like ML Flow. It's same like DevOps, but the only thing is how we work on there is a separate entity kind of the models and the data we work on. For example, you might deploy the applications which are Python based on .NET based and all these things, right? So it's something similar to that, but here we will be using different tools. We will be not using same Jenkins as deploying tool. We might use something relevant to CI/CD. We will be using some other tool while coming to deployment, right? So that's what that differs. And yeah.
So for example, what I'm expecting is in the continuous integration part, the build tasks will be like Docker build and Docker push and into the any container registry, and in the deployment part, take that image and push it into the kubectl apply like Kubernetes deployments into AKS or EKS.
Exactly. So that's it. So
build
here,
and deployment tasks.
Exactly. So that's what like Kubernetes, Argo CD, everything remains the same. For example, so here you get some more extra, that is data versioning. For example, data versioning, what do we use? We use Git or GitHub, right? So here we use DVC. Different tools we might use DVC or LakeFS or something we might use related to that data engineering. So we are just changing the tools. That's it. We are not changing the process. Hope you understand. Right. So for example, model packaging Artifactory and Artifactory, we use JFrog and Nexus, right? So here we use MLflow, S3, registry, something like that. And we'll build the Docker image on top of that. And we deploy to the K8s, either using Blue Green or whatever strategies we use, Canary or something. And we run the integration tests and we promote same, everything remains same. So the tools might vary here and there, but yeah, in the governance we do model lineage and all. And as I told, MLflow we use, and it might be we use Kubeflow AWS SageMaker, Azure ML, something, those models, but everything remains same. If you, that's what I'm insisting. You just get the flow, you just get the concept, and in the training or in the next phase, we can learn on how these tools, for example, the latest tools which we use in the production or which we use in the environment, we can do on that. We can showcase, you can learn those tools, for example, MLflow or SageMaker or TensorFlow, something like that. Argo CD, I think it's pretty similar to what we use in the DevOps, right? So yeah, that's it. Yep. Anything else? I think we thought of 3 hours and we covered it within 2 hours. So yeah, I think Raju.
Yeah, right.
Yeah, I think, can we wind it up here?
Now we can wind it up if no doubts are there.
Yeah.
Yeah, let me stop recording. So okay, really thanks a lot, guys. I think it's been 2 hours that you stayed for such a longer time, and that your weekend. Thanks for really a valuable time. Okay, so kindly reach us. Okay, so I think everybody was there into the WhatsApp group. If not, kindly join to the group. Still, that chat window is having that link, right? So any further communication will pass through the groups. Okay, if you wanted to speak to us for any career guidance or any other courses, also you can reach out to us. Okay. So our people will be always here to help you. Okay, so you can feel free to ping us or call us directly. So don't hesitate to do anything. Thank you so much. Right. So have a good weekend. So great day. Thank you so much. Thanks, Mani.
Thank you.
Thanks, man.
Thank you all. Have a great day. Have a great. Bye.
Thanks, everyone.
Mani, can you end the meeting for everybody?